Hey, and welcome back. So today we're going to get into using uh, the VT100 escape sequences in order to do a bit of a game display using our processor. So originally, a while back, we had come up with this game display, uh, which works, but is just way too slow. So this is actually one of the reasons why I wanted to do the emulation, is to get a better speed. So in this case, it's to actually click on it. If we start it up, you'll see it goes through a test sequence on the characters, and then we eventually get to actually drawing the display, and it's super slow, as you can see. Here we go, drawing the outline. Let's get my highlight going. So, as you can tell, this really isn't going to work out as a game display. We haven't even got our paddle yet. Oh, there's our paddle. And then we were supposed to be able to like move the paddle one way or the other with the joystick, which is just, anyway. So long story short, this was too dang slow. So instead of doing it like this, we're going to do it inside the terminal. So a quick update on what I mean by terminal. So back in the day, before you had full screen graphics, you had a serial terminal, or desktop terminal in this case. So for example, if we go ahead and make sure that's compiled or assembled, go ahead and run it. You'll see, let's go ahead and make that bigger for now. Let's see, this is going to be 28, I believe. There we go, now we can see it, right? So we let that run. You have sort of an output terminal here. You can do things. This is basically the command line in Windows or DOS, if you're that old. And what the codes allow us to do is decide what character we want. I'm basically doing all this up here, changing character colors and the like in order to do reverse video and so forth. And so we wanted to be able to do that here. So we actually created our own little VT100 include file that includes a number of things, like if we want to clear the screen, send the cursor to the home, we want to scroll up, scroll down, do some things like get a hold of characters from the keyboard and then turn them into controls of the cursor on the screen so we can go up and down and left and right. And I've got those mapped to WASD, as one would do for typical modern gaming. Although typically I would have done it to the arrow buttons on my keyboard. So what we need to do to actually send these out is really just send out a sequence of characters. They all start with the escape character. And then for some reason, I don't know why, open bracket seems to be really common in these codes. And then things like this, 1B for down, 1A for up, B for down, C for right, and D for left. And let's go ahead and take a look. What I did was, in order to sort of test out all the different types of codes and to see what they do, I went ahead and created a command for echoing the escape code back to the system. So I can just type in V and the command code, and let's go ahead and do that now. First, let's show, where did my escape codes go? Here, escape codes, where'd you go? Let's get this up here real quick. All right. So this is the ANSI escape code page on Wikipedia. And it has a whole bunch of information, things we can do to sort of control zero codes, or what used to just be control characters on your keyboard. So you'd hit Control 7 or Control 8 and the like. But we're looking down here at the more interesting ones, the ones that start with an escape sequence. And in this case, they start with the escape sequence, or the entire sequence is escape open bracket filled in with some content, and then an A, or in this case, some number A, B, C, D, and that's cursor up, cursor down. It's the number gives you the amount you want to move each time. And then we get, cursor position in general, erase the display, erase a line, all those kinds of capabilities. And one of the more interesting parts for us, of course, is we can italics and bold the text and things like that. Framed, that's interesting. Let's see what framed does. So 51 is the code. So it's going to be escape open bracket 51M. Let's try that. So in my command, escape open bracket 51M, and it does nothing. And this is common. Not all the codes are going to be implemented for every output or every terminal. So not surprisingly, 51 is not framed, is not of an available font, but other things are, like, say, for example, let's say italics, right? 3. So by saying V bracket 3M, we now have italics text, right? Oh, this doesn't look like it's quite the right size. Layout, 80 by 32. Yep, 80 by 32. I think I might have. There we go. There's our bottom line. Let's not lose our whole screen here. So, like I said, one of the more interesting ones, the one that we see up here all the time, is the colors. And that is implemented with a number of color codes. So here, if we want to do a foreground of black, it's 30, a background of black is 40, etc. So let's try and let's just throw what do you want? Let's make it like a green screen. Let's make a background of 42, or a foreground of 32 and a background of 40. And so let's move that over a little bit so you can see the numbers. And go ahead and clear the screen. And we want VT bracket, a foreground of black. A foreground of black is 30. A background of green is 42. And M. There we go, black text on a green background. And now if we clear the screen, we get the full screen in green. Isn't that fun? So this is what was used to, provide color and extra information before we could generate have the memory to generate whole screens of graphics. So let's see, we can go back to normal with the V bracket 0M. Clear screen. But you'll notice we seem to be going pretty slow here, and I'm going to address that in sort of a portrait style so that I can cut it back up into a short. But before we do that, I'd like to do our featured low-level channel of the day, Mr. Ross McGowan. So Ross McGowan's YouTube channel seems to be somewhat similarly concentrated on computer science and applied mathematics, and he has a whole series of assembly language videos in his 16-bit assembly language and his custom processor built in logisim, which, as you can see here, has a reasonable, oh, let's see if we can find the best spot here. And there we go. So there you go, similar kind of layout to mine. Got a CPU and all. Oh, come on now. Well, right in the middle of the crossfade. Ain't that fun? All right, so you have a graphics and a display and a computer and flags and so forth. Same kind of thing, registers. He's got it a little bit less detailed than mine, which is actually more convenient, I guess, for the speed of logisim. But anyway, I'd like to recommend Ross McGowan's channel. If you're interested in the 8-bit CPU, you might be interested in 16-bit CPU as a next level up. And he's got a great deal of good content there. All right, there's our ANSI codes. Let's see. we need to bring this back down to, let's see, what do we want to do this? Let's demo this first. So while we were doing all this, we wanted to go ahead and create some sort of game using this display. And I guess really the easiest sort of game is kind of what I would call an etch and sketch. But I can't call it that because that's trademarked. So we're just going to call it the etching game. And here's the etching game. We just go into G for game, and it puts a solid character. And as we walk around with WASD, we draw boxes. But we can also change their colors by using the number keys. So you kind of get a bit of an etch and sketch style. I was thinking I might, I don't know, draw a flag or something. We'll see. Certainly the flag is the easiest to do. So WASD again, start changing colors. We only have 8 colors to choose from, so it's not terribly interesting. But then we can go ahead and clear that, try something new, all that kind of jazz. And but you'll notice when I go back and print the text, it's just really slow printing of the text. And you'll notice up here we're getting like a good 20 megahertz in the virtual processor speed until we try something like constantly printing strings and our processor speed tanks. So the reason that happens is because our processor thread and our display thread are running separately, and the processor thread puts out a byte on the out the serial port, and we have to wait for the display thread to come around to read that. Otherwise, we'll lose characters. And an example of this is in the new ASCII table entry, where it's not supposed to do this. It's supposed to show a page of ASCII table entries. Okay, that took a while. So what's happening here, though, is that that synchronization is taking so much time, especially on a per character basis. And what we really want to do is have a buffer so that the one thread up here, the processor thread, can just feed the buffer. And when the buffer gets around to being written or drawn, it can draw the entire pending buffer all at once. So to do that, let's go over to the source code. And here's our port write function. And right now, every time we get a byte, see if that's readable for you guys. I sprung for the higher resolution. So every time we get an output byte, we just wait and we set a pending flag, and then we wait for that flag to be cleared. And so now we're synchronized for every single byte, and it's going to take forever. So what I said was, I need a queue. And what a perfect example of a reason to use ChatGPT. It's a very well-defined problem. And so I sprung up ChatGPT and I said to it, hey, write me an enqueue and dequeue functions for a queue of size byte in C language. And it should certainly, here's a simple implementation. Create a structure for your queue, an array of bytes, and a front and rear. Then you initialize the queue, setting those to -1. Got a isEmpty function, an enqueue, dequeue function, and isFull. It's all pretty straightforward. And I thought, hey, that's great. So I block and copy that code into the top of this file. And I didn't mess with making it a separate class or anything, because this is just quick. And sure enough, when we drop in the logic to check if the queue is full, and if it is full, then we wait for the flag, the output pending flag. But otherwise, we enqueue the byte into the queue, and we keep going. So let's comment this line out. Go ahead and build her. Very quick. Then when we run again, I don't know why we're hiding behind the screen, but where'd you go? Lovely. Come here, you. Always crashing for some reason. Wouldn't you just know it? Always crashing during the demo. What fun. Alright, so there's no other copy running. What is the problem? It claimed to copy the file successfully. Yeah. Ah, come on, you. Why do you want to be like this today? Right. Maybe that got it. All right, let's run it in debug and see what's going on. Okay. That's so weird. All right, that's where we hit the port right. We don't need any of these breakpoints. Let's just keep running. There we go. There's our boot okay. And if we do question mark now, it's dang near instant. And that's what I'm looking for. And if we do the test again, wow, that that came out on screen with barely a hit to the speed of the processor thread, I should say. That is quite the improvement. Thank you, ChatGPT. And I, of course, must say that I think the reason ChatGPT succeeded in this case is what I asked for was really just a readily available example that I probably could have found on Google because it's a pretty generic piece of algorithmic, standard algorithmic capability or functionality. So, I think in the sense that ChatGPT didn't lead me down 3 or 4 different, Stack Overflow threads until I finally found the one piece of actual useful code. In that sense, it certainly made it faster. But I certainly wasn't taxing its programming capability, was I? So, in any case, that's a great improvement. The downside is I don't know why it's not running outside of the debugger. Again, let's see. It's not running in the background. There it goes. That's nice and good. Get it full screen-ish. All right. Wow, that is super fast. So now let's go back to our game and see how fast we can actually traverse the screen here. Now in this case, it is actually waiting for another keyboard input, so it's not going any faster than a single byte at a time, really. Because it keeps waiting for my key press. So, let's see. Let's see if we would do a flag. How would we do the flag? Let's see, we need to be blue, certainly. And what is the flag? It is, let's look it up real quick. It is 5 rows of 6 or 6 rows of 5. I forget. I'm sure some elementary school teacher would know right offhand. Let's see. Always love the googly for these kinds of things. That is not our flag. Go figure. There we go. 1, 2, 3, 4, 5 rows of 6 and 4 rows of 5. So let's see, we're going to need a blue space, another blue space, 4, 5, 6, 7, 8, 9, 10, 11. I think that's going to be it. Let's see, we'll go down a space. Now we go over, we want that white. over blue, over white, over blue, over white, over blue, over white, over blue, over white. That looks good. Blue, another blue, white, blue, white, blue, white, blue, white, blue. Well, it's definitely time lapse this later. White, blue, white. Oh no, that one needs to be blue. All right, that's our first rows. Let's go down one more and do it backwards again. White, blue, white, blue, white, blue. There we go. Ain't that lovely? I know, I guess this really isn't technically considered a game, but in any case, we'll get to that. Unfortunately, right now, we've only got a few little pieces more that we need to do. I want to have some box drawing characters. Oh, speaking of which, let's jump out of this and we'll come back to it. Let's see. Run. And there's our ASCII table. That's what I was looking at. And let's see. So these various box drawing characters, the same ones I have around here, I want to create some algorithms to make boxes for me, or as one could possibly call them, windows on the screen. And in those windows, there will be, messages for the game. So that'll probably be the next thing we do. I think right now I'm happy that I managed to get this far, and it's a sort of a win for ChatGPT programming. Wasn't too terribly extensive, if you will. But anyway, so that's going to be the next one, and that's going to definitely take a while. And let's go back to doing our flag, shall we? Let's see. That is, well, let's see. It is, of course, G for the etching game. And we start over because that's what happens when you dump out real quick. So let's just 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe? I forget. Anyway, we'll find out here soon enough. Oops. That wasn't quite enough, was it? So this first row. Oh. There we go. I keep hitting the arrow buttons. But anyway, I'm not used to the WASD of gaming. So that's a blue, and then that's a white. There we go. Do this again. I'm gonna actually get kind of good at this right when I'm done doing it. Ain't that just the way? Let's see, 1, 2, 3, 4. There is 6 rows on top. 6? No, 5. That makes more sense. All right. I know all the elementary school teachers are screaming at me right now. Oh, how do you not know? There we go. And go over one. That's got to be blue. Go down one. And that's 3 of the 5 big rows. Oops. Up and over again. Right, down and back the other way. Whoops. There we go. 1, 2, 3, 4. One more row. Or 2 more rows, technically. Looks like it's going to be kind of a squished flag. Whoops. You're blue. And you're blue. And you're white and blue and white and blue and white and blue and white and blue and white and blue. And blue and blue. Down and white and blue 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 and blue. All right, we got 1, 2, 3, 4, 5 rows of 6 and 4 rows of 5, and that should be the right number of stars. Let's finish off the row, or the blue field rather. And let's see, just below that we have the white field, or white lines rather. So, what do you think? Round about there? Sure, that should be enough. Then we'll go up and go to red. The line should be the easy part. I think 2 rows each is going to be enough. Let's see, we got 1, 2, 3, 4, 5, 6, 7. 7 rows, yeah. All right. Wait, and go up and go back to white and zoom back over. Try not to erase my blue field. White again. Oops. Oh, darn it. So here's my problem. I never did program a black. So best I can do is gray it out. That's kind of annoying. But whatever. White. And then up, and it's red. And then now we get a red line. Up and back. I don't think this is going to be enough lines. Let's see. 2, 4, 6, 8. And no. Dang it. Well, that's not really going to work, is it? We're going to have a bunch of uneven lines and sort of combinations. So what do you know? We made a checkerboard with a racetrack. Checkerboard racetrack. There we go. Close enough. Should have done the Texas flag. It's so much easier. Anyway, we will come back and look at that later. Probably needs more lines. And let's see. What else do we want to show? Let's see. So what we want to eventually get to is making those boxes. So let's go to our string lib. We have a number of constants. And maybe we make a different box lib. I think no. Let's just create some constants for these characters. And since I don't remember all the characters, we'll pop open our display. There's our ASCII character set. And we're going to start off with these double line characters that we are using up here. So we have the, minimize all this so I can see what's going on. Where'd you go? Where'd you go? There we are. All right. So we're going to use, let's see, C9 and of course BA. So let's get all the corners. So C9, and let's draw a minimal box. So C9 is going to be, what do we want to call it? Double double box, and it's the upper left. Double box UL, and that is 0x C9. There. C9, 9, and then the double box, I guess we'll just call it line. Maybe horizontal line? No, horizontal bar. Yeah, let's call it horizontal bar. Now, horizontal bar is the one that is drawn up here in the middle. So horizontal bar is CD. 0xCD. Make a constant of double box. Horizontal bar, upper left. And we got upper right. And the upper right is around here somewheres. BB. Not sure why C9 and then BB. It don't seem to be in any sort of order. And we got our double box vertical bar. And vertical bar is BA. That's easy enough to find. Then we got our double box. And that is the upper right. So this is going to be the lower left. In the lower left, there's the upper right. There's the lower left. Where'd you go? Where'd you go? You're around here somewhere. Oh, come on. Gotta be around here somewhere. That's the crossbar. Right. Left. I am not seeing it. No, it's somewhere in this sequence. I'm blind to it. I know it's this character though. Unfortunately, I can't just click on here and see the character. I could revert to looking at my source code, but why do that when I have the documentation right here? So it's got to be one of these shortly. Where did the character go? C9, C8. Ever get that time when you're looking for something and you just seem to be blind to it, even though it should just be right in front of your face? Like somewhere right in front of your face. One of these single characters is the right one, and yet for some reason I am unable to see it. Aha, BC. There we go. This should be right next to each other, right? You'd think they'd be more next to each other. But BC. Oh, now I'm beginning to see a pattern. These are all sort of lower right corners, but with different numbers, right? This is the double box. This is double to single. This is single to double. So BC. CE. Then we already have the vertical bar. So all we need now is the double box lower right. Double box lower right, which is C8. All right. So the reason I make them constants is so that they're a little bit easier to put together, right? So, and let's see, where do we want to put it? We're going to put it inside the test function. So come down here. These are all our different capabilities or different commands. And then let's just test func. There we are. And here we are where we were printing all this out over and over again. We don't really need that. We'll keep the one. And I don't know how many times there's been in my life where I have printed out this sequence of characters to decide where to put my boxes and so forth when drawing using the terminal. So for each of these, let's see. What we really want to do is make sure we save them. So if we're going to draw a box, we kind of laid it out like this. We're going to need the upper left. We're just going to write these all out individually to the serial port. And since they're just characters, we don't have to worry about setting a color, but go ahead and let that put us into red on black mode. And we don't need to print that. Instead, we're going to do a whole bunch of write to the port 1 from EEPROM, and our EEPROM is going to be our upper left. Then let's just block and copy this a number of times. The middle one, the next corner, the vertical one, the next corner, the one in the middle, and the final corner, and the vertical one again. So upper left, what all did we call these? Let's go ahead and move these to the other view so I can see them while I'm doing this. So upper left, horizontal bar, upper right, vertical bar, lower left, horizontal bar, and then lower right, and vertical bar again. So that should give us a nice little box that we can, it's not going to be a very little box, but that prove out the basics of it. And then what I think I'm going to do is, create a function that says draw this box by repeating the horizontal however many times we need and repeating the vertical however many times we need whilst putting out the corners. So let's go ahead and just see how that looks. Exit out of there. Rebuild. Rerun. There we run. Test program. Whoops. Well, that didn't work so well, did it? We got the first part of it, but we just started printing like that. So what we really need to do is move the cursor down and over when we're done. So in this case, we could print out the box. We could print out the box just like lines, but what I want to do is show the VT codes of being able to move the cursor around as we draw. So as we saw before, the cursor moving commands are things like escape, 1A through D for the direction. So we're going to do VT down. So let's do this again. Get back to our test function. And so there's our upper left or horizontal bar, or upper right. Now we want to go down and back over one character because each time we print, we move over one character. So now we want to go down and back. So we will load the VT down sequence. Call print 1 to port 1. Keep doing that. String port. Print string 1E, and it's a tab character. So that'll give us our down. Now we want to do one character to the left. So that's VT left. Now we could just keep going around like this, but the fact that it auto sequences to the next character makes it easier to go back to the beginning of the line and draw this. But by doing it in a circle, you'll see later on when we get into how we bring these up on screen and erase them, they're going to look better by drawing them in a circle and then erasing them in the circle rather than erasing them as lines. So we went down, we went left, then we're going to do our vertical bar. And we need to go down and left again. Do our lower left corner. And we don't need to go down now. We just need to go left twice. Now, we could change this number here in the left string to do more than one. But really, it's not all that difficult to repeat the line, if you will. So we're going to go left once. Actually, we're going to go left 3 times. Let's see, we got box, 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 down, printed, down, printed. Now we need to go back twice. And we'll print our horizontal line. Then we'll go left twice. Print our lower right. Lower right. Well, yeah, that looks correct. That looks like the correct sequence. Lower right. Did I miss? I might have put those backwards, did I? Lower right. Lower left. I get those backwards. I don't look backwards on here. Anyway, let's just see how it goes. So we went and we said draw the first 3 characters. Then we're going to go down to the left, print the vertical bar, then down and to the left. And we don't want to print the lower left. That's when we want to print the lower right. Unless I have them completely backwards. Well, let's just try it the way it was. Lower left should be lower right. Go left again. Another horizontal bar. Go left again. The lower right. Then we need to go left and up 1. That's left. And then 1 up. So all these are doing is loading up these individual constants and printing out this sequence. The /e is the escape character, and then the rest of it is standard VT100 terminal code, except I end it with an escape as well, and that's just for synchronization purposes on my end. Makes it easier than having to know all of the VT100 codes. They're not a standard width. You can, in theory, keep that open bracket going, putting in all sorts of different extended codes, but keep it simple as it were. So that should print us our box. Let's see what happens now. Cut that out later. All right, and we're running. And we're running with gas. Here's our test screen. And sure enough, we get our nice little box. That almost looks intentional. But what we did was we didn't move the cursor down, or rather we left the cursor here, so the prompt got printed out thusly. So after we print the circle, we need to go down 2 more lines for our prompt to be where we really want it to be. So let's do that real quick. Jump back to our test function. You can see why assembly takes a lot of pages. There's not a lot of comment in between, or not a lot of content on each line. And I know there should be comments, right? Let's go ahead and give it some comments. Let's see. Set red on black. And this is upper left. Horizontal bar. And upper right. I hope those make sense to you. Then we're going to move down and move left. And this is why I end up not doing so many comments, because if you have nicely named variables, the rest of this is understandable, right? It's understandable that it's a VT code because it starts with VT, and then the all caps down, left, up, right, etc. So move left, and we'll just let's comment the characters that we need. So this is the vertical bar. And then down and left, and this is the lower left. Although I could swear it is not. This should be lower right. And this should be lower left. And it might be that we need to redefine them over here. So this should be lower right. This should be lower left. There we go. Things nicely redefined. And this is, wait. Vertical bar. This isn't lower left. Lower right. There we go. Then we got horizontal, whatever, horizontal bar. And then we've got our lower left box. And then when we're all said and done, writing our vertical bar, we need to move down just a couple more. Right, so VT down, down, and then we reset our colors back to where it was. There we go. Assemble. run test. There we go. Now we got a nice little box. And what we can do is we'll create a function around this incredibly annoying set of commands and decide how many more we need to print each time and how many more we have to go back and all that jazz. So I'll probably come back online later tonight, maybe tomorrow. We'll see. And we'll do a little bit more of that. But that's our basic box drawing. And we have, oh, actually, look, we missed a spot. So let's fix that real quick before we forget. And that is, let's see, VT home command. Let's see, I just want to go back to there without a carriage return though. Do I want to do a carriage return? Maybe. That might be the simplest. Let's see. Set foreground color, background color. Here is a cursor save. Let's see. Scroll up, scroll down. Erase inline. We can set the cursor position. One based. Let's see. Does it do I just need the sequence and the N, and the N is the row, so maybe all I need to do is bracket 0 and then capital H. So let's see how that looks. We'll bring our back up. There's our ASCII table. So if we do test again, so what we want to do is see if escape bracket 0H. Yep, that brought our cursor back to the 0th row on whatever, or the 0th column on whatever row we're on. So let's just throw that command in for what do we call that? It's kind of like a carriage return, but it doesn't increase the row. So for example, if I did this command again, v bracket 0h, oh no, it didn't. Well, because it printed the carriage return. Well, that's not very useful. Let's see what it looks like when we do something other than 0. Say 10. I think it's because I'm hitting carriage return anyway, and I'm echoing a carriage return for the command. I'm kind of messing this up. I probably shouldn't echo a carriage return on these VT commands. So let's see. Go ahead and clear the screen. Print out all the things we got. ASCII table. So the idea is we can use these sort of special drawing characters as our building blocks for our good guys and bad guys. And then I was originally thinking of doing something like Breakout, where the cursor moves back and forth and the ball bounces around and that kind of thing. But it might be better to do something more Space Invaders-ish. I say ish, very ish. So let's see. We'll have to decide what characters we want to do on all that. But we can make them out of these block characters. And I think if I change the font on this display, let's see, let's change the font real quick. And there are VT commands to change the font, but it doesn't look like any of them are supported. So let's see, we want it to be a console font. Let's try that. Consoles. All right. Looks like we're off by a row here. There we go. And let's clear screen, run the test again. The ASCII table. So one of the, yeah, that looks better. That looks like that's filling the whole gap, right? So let's see what the etching game looks like now. Yeah, there we go. See, now everything's all lined up. And we could actually do other characters, right? So besides my field of blue, I would want to do, say, an asterisk character. I'm not doing here, but I'd like to draw the flag with asterisks for stars, and those stars need to be white on blue. And so we'll add some other capabilities to our little etching app here next time. Let's turn it to green, maybe red. There we go. Yeah, I think I like this font better. It's a little more compact. It's tall and skinny, so the aspect ratio is a little weird, but at least they all touch each other. All right, quit out of that function. And let's see, what else do we want to show? Let's see. Hey, thanks. All right, what else we got? Oh yeah, we got our little box function. We need to functionalize that. Functionalize it with a number of. So, I don't know if this will work or not, quite frankly. Probably not. But there is a way to store the current cursor position, do some drawing, and then restore the current cursor position. But I'm already doing that to draw this top part of the display. So I don't think I'm going to be able to do that inside this portion of the terminal. But we'll see. We'll fiddle with it a little bit and let you know. All right, what else are we looking at? Yeah, let's go ahead and functionalize that. Why not? We got some time. Let's create ourselves a box drawing file. Start that. Let's create a new. Let's see, box drawing. And bring it back up here where we can reach it. And save it. Box drawing ASM. It's in my language. And then let's start let's go ahead and pull these out since they're only for box drawing. They don't need to be in the generic strings library. And we can define them at the top of this. And later on we'll do the single ones as well, because I think eventually we're going to want the ability to put a caption on a window and that kind of thing. So sure we include boxdrawing.asm program. Save build should be the same. There we go. Pretty much the same. You see this is our ruler for deciding where to position things. And we can do math to center them and that kind of stuff later on. But the more we do up front, the more straightforward it will be in our code. Oh, there's still got that problem. Why is that still a problem? Oh, we never actually put in the command. That might be why. So in our box drawings, not box drawings. It was the VT100 library. Oh, well, we didn't even have it in there. So that's left, right. Let's go ahead and put in a define a VT. What do we want to call it? We want to, it's I guess it's technically it's a straight carriage return. The line feed is when you move up a column or up a row. It's not really, we'll call it the VT carriage return. Why not? And it's going to be a string. It's going to start off with the escape character bracket 0 and H. And we end the escape sequence with another escape. That's only on my system. And we put in the null terminator for the string. And VTCR goes here. And we load the address of that and call print on VT carriage return. There we go. Symbol. Run it. Run a test. Oh, where'd we go? Oh, that's right. Everything's 1 based, not 0 based. So it should not be a 0. It should be a 1. And it was a capital H. Yeah, capital H. All right. Build. Run. Run our program. Oh, we went off into the weeds. Why in the world did we go off into the weeds? Well, that is quite confusing. Let's see. No complaints in the symbol. Huh. Well, that is quite confusing. Because that is just running it. What in the world did the winter wrong? Yeah, that's why we have a debugger. So let's bring it up in the debugger. And it runs fine, of course. Ain't that just the way? Oh, I know what I did. So every time I hit these keys to compile and assemble, or assemble and run, they have to be running on the main program. If I assemble and run from here, it's not going to work right. So that's what I'm doing wrong. I'm not going back to the main program. There we go. Our test, still going off into the weeds. Not. Oh, maybe did we not build it? Build it, run it. Oh, that gave us row 0 or row 1, not column 1. Did I read the command wrong? Let's see. N semicolon. Oh, I need the semicolon. That's why. It assumes 1. So row, column. So really, we just want to change the column. Interesting. It'll default back to the, Yeah, maybe that's not so good. And instead, maybe we just use regular carriage return then. And we won't need the second down. So what I mean is over here in Test function. Let's not use that one. And we won't need the second down. And all we really need to do is write 1e, a real carriage return. And maybe that'll do it. In the actual function, we're going to have to store the current cursor position and then restore that cursor position when we're done drawing our box. And so we're going to need to know our cursor position all the time, which right now we're not bothering to keep track of. So we build, can't have old copies running. Do we still have an old copy running? Doesn't look like it. Well, to open map files for those. It should not be a problem. Our debugger is not running. So what in the world is causing that, I wonder? Things that make you go, There's something hanging. This is really weird. Hate when that happens. So maybe we'll debug that separately. You see me do it, it doesn't tile. There it goes. So this has just got to be some Windowsism where the files aren't readily available. Maybe the debugger had them locked or something annoying like that. Who knows? Anyway, here we are running test. Oh, so close. So close, but one too high. So it turns out we did need that second down command. Obviously, substituting the numbers instead of having to say down over and over and over again is definitely going to be useful. Although it will kind of limit our, might limit the size of our windows. Right now, I just want a little window around some text. It's not that difficult. It shouldn't be that difficult, but everything's difficult when you're doing it in assembly, right? Oh, not really. All right. There we go. Build, run on the system. T for test, and that's what we're looking for. Yay! Woo. We have a little box drawn here. Gotta love the small successes. Now let's see. Yeah, do we want to functionalize this now? I'm gonna have to do some more investigation about how to go about tracking our cursor position. We're probably gonna just have to have it built in. And then every time we send in a character, we're gonna have to know that our cursor position moved, because unfortunately, unlike the real terminals, I can't get the information of the characters on the screen back out. Not that I know of, anyway. So once it's drawn, it's forgotten, unless I keep track of it myself. So let's see. Let's go ahead and move this into our separate API. Go. Here's our set red on black. Draw the box. And cut that out. Go to box drawing. Define a function called, what do we call it? Draw double box. for double line box. And those are all the commands for drawing the double line box. In red and black. So, we'll have parameters for this function, like what colors we want to set, or we can just let this be set before we call draw double box, which is probably going to be more straightforward for us. So let's put that back over here. Now we're going to call the function that we just defined of draw double box. Hi, everybody. How you doing? Feel free to ask questions in the chat. We're just kind of winging it, going as we go. We got a number of things. I've got my coffee's all cold already. Just in case you're new, what we're doing is we're writing assembly in our own custom processor that we built from the ground up. So we have our own instruction set and issues and restrictions and complications all on our own. But let's go ahead and there's our draw double box. Eventually we'll want to, put some parameters on the stack. So we'll want to push onto the stack things like the width and then the height, and then probably, some content in the middle, maybe a string of text to put inside the box. But for now, width and height would probably be a big enough task. See and do a quick time check here. Yeah, that's probably going to be more than enough difficulty for the time we have remaining. So first, let's just make sure we didn't screw anything up and we still draw a box like we thought we would. And run on our target and run the test routine. And besides some extra blinkies and our cursor going off in the weeds, oh, we actually went off into the weeds again. Let me guess. Was I not on the right window? Yeah, because our instruction pointer is off in the weeds. Here's an 11. 11 is a halt instruction. So everything that isn't defined gets filled with a halt instruction. Or we actually hit the halt instruction. I thought that was commented out. Okay, maybe it was our glitch. There we go. Run test function. Again with the halt. Where are we getting this halt instruction? Oh, we're getting reset into the weeds. What are we doing? Oh, I know what we're doing. We're never coming back from this function because we never said return from function. Now we should return from the function. We were just going off into the weeds forever afterwards. And the system rebooting because it eventually gets to the end of memory and starts over. There we go. Now we're behaving. All right, that's why we do the basic test first. So now let's see. In order to push a value on the stack is pretty straightforward. Now, mind you, we're only dealing with 8-bit values, so the box is going to be limited to 256. But let's face it, we've only got 80 columns and 25 rows. We don't need big digits here. So let's see. To push the width, we need to load a value for the width into a register. So let's load a value into A. Let's just make it, like say maybe 4 by 4. So there's going to be 4. So we're going to load 4. And we have to put everything in hex in their assembler. And then we are going to store that on the stack. And To store that on the stack, we need to run back to our assembler, or rather our documentation. Come on. There we go. So if we take a look back at our documentation, go away. So we'll see, get down here is our assembly grid. And our assembly grid has us storing on the stack. So slow today. So to store on the stack, we want to use reference RAM via the stack pointer. And we're going to store the A register. So that's store using the stack, the A register. Come on, you. So store using the stack, whatever's in the A register. Then we're going to LAE again, our height, and let's make it different so that it's, noticeably different. Let's make it 4 by 5. Actually, it's a little taller than it is wide. So maybe we'll make this 4 and this 5. And then SCA again. And push the width. Push the height. Then we're going to call draw the double box. And now inside the draw the double box function, we need to know where these two are relative to the stack pointer. So let's come up here. We'll create another couple of constants. One constant is going to be, let's call it draw double box dot width. And it's going to have a constant because that was the first thing we pushed on the stack. Now, when we call the function, we have 2 more spaces on the stack. So for the width, we've got -2, this is -3, and this is -4. I believe. We'll see shortly. So we want that to be 4. And then draw a double box dot height is going to be 5, or 3 rather. Now, so we draw our upper left corner. Now we need to draw, we're just going to assume that the box is positioned first. You put the cursor where you want it, then you call this function to draw the box, is the assumption. So we need to do a loop, width number of times, duplicating the horizontal bar. So the fastest way to do a loop is to load a value in and decrement until we hit 0. So first off, let's load the value into, or rather, load the location of the value, the width, into the data register. So what POE does is it takes the current stack pointer and adds this value to it in order to point at the place that we pushed it earlier. Now that we're pointing at it, we can load into A from memory or DRAM wherever this is pointing. So that gives us our value into A, right? And then we can load the character that we want into B, the one that we want to put out over and over again. So let's load B from EEPROM, and that character be the horizontal bar. Now we've loaded the horizontal bar into B. We have the number of times we want to do it into A. So now we're going to actually write to port 1 whatever's in the B register. That's the first time. Then we're going to decrement the A register. So we subtract 1 from A. Then we're going to jump a small distance, if it is not 0, back up to where this point. So let's define this point as draw double box dot horizontal line, something along those lines. It can be whatever you want it to be, however readable you need it to be. So now we're going to jump back to this location that number of times. So what this does, we load the width into A, we get the character we want to print into B, we write that character out from B to the serial port, decrement A, so it's 1 less, and then if we've hit the end of the character count, then we exit out. Now this will either do it 1 too many or 1 too few times. But let's just see what we get. We should at least get, we don't need that extra horizontal bar. Let's see. For a Z bar. Let's see how that works. I think that should get us there. Now, when we come back from this function, there's going to be extra stuff on the stack. So after we're done calling the function, we have to increment the stack once for each variable we pushed on the stack, and that pops it off the stack effectively. Rather, sorry, that pops it off the stack without actually doing anything to it. It just adjusts the stack pointer back to where we were so that when we return from this function, we don't go off into the weeds. And so let's make sure that all behaves with a quick build and a run the target test. Well, that seems problematic. Why are we going around in circles? Didn't go around in circles. I'm going to get copyright strike for my bad singing renditions. So to debug this, we're going to, let's see, clearly we never get out of this. So decrement A, well, it might be that we're loading a very large value and we're not looking at the right spot. So to find out if we're looking at the right spot, we're going to start single stepping. So here's where we start putting stuff in. So let's do a halt and a no-op. That's my version of a breakpoint. And then we'll single step from here. So in order to single step, let's move this a little off to the side here where it's a little easier to see. Save before we build. It will not save for us. There we go. We run test string, and there we go. We've hit the breakpoint. So let's move this over here. Let's just see, move that like there, and then it turns out we don't need most of this. So let's just minimize that. All right. So now let's single step. We're going to load into A this value 5 that you see here, and sure enough, there it is. Then we're going to store that on the stack. Our stack pointer is triple FD. So that gets stored. We don't really see it go by because we switch back and forth too fast. But we'll see that shortly. So now we load 4 into A and store that on the stack. You can see, however, how the stack pointer is changing. So now we're going to call the drawn box, which will put our return pointer on the stack. And let's see. So the first thing we do is draw that character. Then we want to load the width character. And sure enough, our width was 5, right? So load 5 into A, right? Then we're going to load, actually, I don't know why I'm loading it into B and just to write it out. I could just write it out directly. But anyway, load it into B, write out the horizontal. And we decrement A. Sure enough, it's 4. Jump if it is not 0. Back up here. Oh, dang it. See, I'm loading the original value each time, so of course it never decrements. So really what we want to do is not load the original value. We don't even need to reload B each time. We really just write B, decrement A, and jump back to writing B until we're done. So there's our problem. Make sure we're on our main program when we build. 5, test program, and we hit a breakpoint. And I'm reasonably confident this worked correctly this time, so let's just run. There we go. We got our extra columns. We haven't started looping the rows, but we certainly got that. Let's see if we can make it bigger. So we go ahead and take out that, move this to say a 10, which is hex capital A, build, run again, test program, and sure enough, you can see we're getting, it's actually 12 characters because there's 10 in the middle. And the corner pieces are not part of it because you really can't draw on the inside of that. So we got our width is 1. So now let's deal with the width. So our box drawing. Here's our top line. This is actually our, and I really don't need to. Yeah, it's only, it should be just barely marginally faster to do it that way. So, all right, then we're going to do the upper right. And then we're going to do this loop where we move down and left and print each character. Now, I thought there was a VT100 command that said just change the character where the cursor is and don't move the cursor. I haven't been able to find it. I thought for sure it was there. But anyway, we can include this in our loop. So we need to load the height off the stack. Then we need to load that into A, B of the vertical bar, and so there's our vertical bar, but we wanted to do the down and left. So yeah, do the down and the left, and this is where we're going to loop. So we'll define here the draw double box dot. That was the horizontal line. It's really the top line. So this will be the right line. And we do down and left and right 1E are actually, well, we loaded it into B, so we can write 1B. And then we're going to decrement A and jump a short distance if it is not 0 back to ddb.rl. So now this should do our moving down and drawing the right-hand bar character. I believe that's enough. Do a quick build, quick test. Well, it moved down. It just didn't draw our bar for us, did it? It did certainly move down. What happened to our bar, I wonder? So, here's our loaded our vertical bar into B, right? So we come in here. We go down, left, write our character, decrement A. And if not, come back around. That should be it. That's a little weird. Well, I'll work through all this. And hopefully next time I'll see you, we'll have a nice little box character and we can start drawing in some other characters like the shields that you hide under when you're shooting your missiles and things like that. So let's see. What is going on with this? Now, I believe what's happening is when I call the print function, I'm destroying my B variable. And so I'm not going to be able to just load it once. What we're going to have to do is change our loop location to above here. We're going to load the value, do the vertical bar, go down, left, right our vertical bar rather, decrement A, and then let's see, decrement A, then we need to store A back where it was. So we will load the location of the height. We're going to actually destroy the height value as we go. Then we want to store using the stack the A variable. Not the stack. We're not storing in the stack. We're storing using the DRAM. So we're just SIA. That's the one. Looks like I'm coming up on my time spot. So what this will do is now we'll actually store the value each time and then read it back. There we go. Build, run. Oh, that's a convoluted mess. Whoops. Well, we'll get that worked out and come back to that. All right, it's been fun. Have a good time. We're going to go off and do some other things now, and we'll chat with you next time. Oh, we're not going off. All right, well, we'll keep going then. See if we can't figure out what's happening here. So let's see. Our box drawing. So that should have stored. Let's see. All right, we get the height address of the height. We load the height. We load our vertical bar character. See, we're destroying our B value. So let's just take this, come down here, and instead of the right 1B, we can write 1E, the vertical bar character. And then that should make sure we have something to write. And decrement A, store A, load the address, and store A back in the address so that when we loop around, we're not stomping on it with these calls to other functions. So, and we probably should have done that up here too. There's the puppy. All right, let's give her a try. Oh, we don't seem to be stopping. Oh noes. What can we do about this? Well, we can halt and see where we actually are. That's in the print function. So I think F7 is supposed to return. There we go. So we print the vertical bar, decrement A, load the location of A, store A. Why is it 23? Where did it go off into the weeds? All right. When in doubt, reboot. But besides that, let's go ahead and put another halt and no op. And let's do the debug. Build with the debug in spot. Run the code. There we go. Now, let's see. We're going to load the height. Sure enough. Or add the address of the height, which is 4. 4 and A, right? Was that it? Yeah, 4 and A. That's what we said. So now we're going to load VT down and print screen and VTF and print that. Now we're going to write out the vertical bar, which is in the right spot. So good. So far, so good. And A is 4. So we decrement A. And then we're going to load that address again. Store it. So now it's decremented to 3. Now our not zero flag is set because we didn't decrement to a 0. So we're going to jump back up to here, right? And that's where we load the address of the height again. And it's now 3. Load 3 into A. All right. There we go. Load that, print that, print our vertical bar. So we seem to be doing okay. And what happens? Where does this go off into the weeds? We decremented to 2. Ah, so these are destroying our A value as well. So, yeah. So now we're at 1. Decrement A. It's now to 1. Store it. Jump back. Load the address of A, or the height. Read it back out. Right there. Okay. I read that out. We decrement it to 0. We store A. Then we're going to jump. We should. Why is our non? Jump short if not 0. Which it does, but A is already 0. So I think what we're going to do, first off, let's do this reading and subtraction outside of these function calls so that A won't be stomped on by the function calls. And yeah, let's see if that that does it. Decrement A, save it off, and so the POE function actually uses the t variable and does math. And that math overrides the other one, the decrement function from above. So I think we can probably, so we could rearrange all this. The other thing that we could do is just load it into B. Because anytime we load into the B register in our architecture, we reset all we reset the non-zero flag based off of the contents of the load. But I think I can get rid of this problem by doing this command first. And then this will be the last math. The decrement A will be the last math function that we do before we do the jump based off of the result of that math function. So let's see how that plays. Save all that. Let's escape out of here. Here we go. Build. Run. There we go. We hit our breakpoint. Let's just run and see what happens. Hey, at least we didn't go off into the weeds anymore. So sure enough, we managed to get our width and our height. Now we need to do our width again to get back this way. And so roughly the same logic as our first one. And for now, we don't want to halt break here anymore. So let's go down here. Let's see. There's our lift for that. Then we do down and left. And the lower right. And then we do this loop of left, left, horizontal bar. So left, left, and horizontal bar. We want to, let's see, that's the right line. So this will be the bottom line. The bottom line. Let's see. So let's define, draw a double box dot bottom line, because we're going to need that label eventually. Then kind of the same thing. We're going to do the two cursor moves first. Then we're going to load up our width. And luckily we didn't destroy our width. Now that I think about it, we done destroyed our height. Well, we might have to do that differently. But now drawing the height again, maybe the best way to do this is to divvy it up even further so that the box function is broken up into draw top of box, right of box, left of box, bottom of box, left of box, and just do that as 3 separate functions, because what's happening here is I'm destroying the temporary variable or the past variable in drawing the right hand, and therefore I can't draw the left hand side. But if I put them in separate functions themselves, then I'll be better able to do that. And this won't be quite so messy. So yeah, let's think about doing that. And I think that's pretty much what I had for today. So thanks for joining us for however long you did. Be sure to like and subscribe and all the usual fun stuff. And we'll be seeing you next time. I've got something new and interesting to show. Have a good one.